tiny miracle. Lots of cables, some blinking lights. That's networking. Honestly, that is just a perfect description. Because every single time you stream a YouTube video or jump into a Zoom meeting, you're actually relying on this invisible, miraculous system that's just working tirelessly in the background for you. Welcome to today's Explainer. If you've ever found yourself wondering about the exact mechanics of how your data zips across the entire globe in mere milliseconds, well, you are in exactly the right place. Today, we're going to unpack the foundations of computer networking so we can build a rock-solid understanding of this digital web. Here's our roadmap for today. We're going to look at the invisible digital web, talk about why we actually build networks, unpack the networking toolkit, size up your network, look at how data actually finds you, and then wrap it all up with a big picture recap. Let's dive in.
Part 1, the invisible digital web.
So, what exactly is a network? At its core, a computer network is simply a group of connected devices that can communicate with each other. Now, it's not just those bulky desktop computers we used to have. It's your laptop, your mobile phone, servers, routers, even your smart TV. When your phone connects to Wi-Fi, boom, it becomes part of a network. When you open Instagram or do a Google search, you are using computer networking. The whole shebang is really just about devices talking to one another. Section 2. Why build a network? Connecting all these cables and blinking lights definitely takes effort, right? So why do we even do it? Well, picture this, an office with 5 computers and just 1 printer. Without a network, you'd literally have to buy 5 separate printers. That's super expensive and totally inefficient. But by connecting all 5 of those computers and that single printer to the same network, every single machine can easily share that exact same resource. It's a real game changer. And that resource sharing idea leads us right into the 4 main drivers behind why we built computer networks. First up, sharing data, like sending files or firing off emails. Second, sharing resources, whether that's a printer or a shared internet connection. Third is communication. Networks are what power every single video and voice call we make. And finally, increasing business efficiency by allowing secure access to shared databases from anywhere in the world. Whether you're making an online payment or just playing a game, this is the why behind all the technology. All right, moving to Section 3, the networking toolkits. Let's look at the physical and digital components that make these networks actually function. First, consider the router. Now, a router is a device that connects different networks together. It kind of acts like a bridge. So your home Wi-Fi router, it bridges your small local network of phones and laptops right out to that massive global network we call the internet. Now, contrast that router with a switch. While a router connects different networks together, a switch connects multiple devices inside the exact same local network. It basically helps all the devices in one space communicate smoothly and directly with each other. And notice the sort of conversational relationship happening here. In networking, devices usually play one of 2 distinct roles. A server is a very powerful computer that provides services or data. A client, on the other hand, is a device that requests those services. So when you open a website, your phone is the client requesting the data, and the web server actively sends that web page back to you. It's this continuous, nonstop digital conversation of asking and receiving. Section 4, sizing up your network. Networks actually span vastly different geographical scales. The big 2 you'll hear about are LAN and WAN. LAN stands for Local Area Network. And just like the name implies, this covers a small local area. Your home network, a school lab, or a single office building. Those are all LANs. On the flip side, we have WAN, which stands for Wide Area Network. A WAN covers a large geographical area. In fact, the internet itself is the absolute best and biggest example of a WAN, connecting billions of devices globally across cities and oceans. Oh, and there's a really common variation of this that you probably use every single day called a WAN. That simply stands for Wireless Local Area Network. It is exactly the same concept as a LAN, but it uses wireless technology instead of plugging in physical cables. So when your laptop connects to the Wi-Fi at a local coffee shop or at your house, you are using a WAN. Which brings us to Section 5, how data finds you. The magic solution to routing all this data is the IP address. It's essentially like a home address for a device on a network. Just as your physical house needs a mailing address for the post office, your device absolutely needs an IP address to send and receive data. The source material hits the nail on the head here. Trying to route data without an IP address is exactly like ordering food with no delivery address. You're just going to end up lost and hungry.
Let's put that into a quick timeline to see how it flows. First, your device sends a request using those IP addresses. Then, a server receives and processes that request and fires the data right back. Finally, your browser displays the website. This entire journey across cables, routers, switches, and servers, it happens in mere milliseconds. Behind every single tap or click you make on your screen, this exact three-step sequence is firing off.
Section 6, the big picture recap. So, just to bring it all together for you, computer networking is what connects our devices so we can share data and resources. We use specialized hardware like routers, switches, servers, and clients to actually make this happen. And these networks can scale all the way from a small local LAN in your living room to the massive global WAN of the internet, all relying on IP addresses to make sure your data always finds its home. I'll leave you with this thought. The internet is just a massive web of connected devices. The very next time you click a link or stream a video, pause and ask yourself, which local and wide area networks is my data traveling through right now? What routers and switches is it bouncing across to get to me? Thanks for joining me on today's Explainer, and keep asking great questions.